Okay, we're looking at the second set of questions, starting at question 6 on the Moodle assignment. And it says, evaluate f negative 2 for the function f of x is 5x minus 5. It just says evaluate, plug negative 2 in. So f negative 2 is the same as putting negative 2 in where those x's are. So we take 5 times negative 2 minus 5. 5 times negative 2 is negative 10, and negative 10 minus 5 is going to be negative 15, which is E. All we're doing, if it says evaluate f of negative 2 for f of x, means when you put that negative 2 that's in the brackets there, that just gets shoved into the x variable. Just evaluate, nothing tricky. Next, evaluate f of negative 2 for this other function. Same deal, just put negative 2's in. So we have 5 times negative 2 squared plus 2 times negative 2 minus 5. So everywhere there was an x, I put in a negative 2. So 5 times negative 2 squared, anything negative that gets squared becomes positive, and 2 squared is 4. That's 5 times 4, which is 20. Start on my next line already. 2 times negative 2 is negative 4. That stays negative 4, nothing to do there. And negative 5 is still negative 5. So 20 minus 4 minus 5. Just going to double check because I don't trust myself. It is 11. So 20 minus 9 is 11. We choose C. Next, for the function g of x equals 3x minus 8, determine g of 3.1. It's the same thing. Take this 3.1 and put it in where there's an x. So g of x is equal to 3 times 3.1 minus 8. 3 times 3.1 is 9.3. And 9.3 minus 8 is 1.3. So this option here, it's not a function because only f of x can be a function. That's not true. You could have g of x, you could have f of x, you could have h of x, you could give whatever letter you like there. It's just sort of a way of keeping track of which function you're looking at that particular time. This g or f or a or b or whatever, they could be whatever letter. And this is the reason for that is in the future you may be dealing with lots of equations at the same time, and you don't want to call them all y because that gets confusing. Next, for the function g of x equals 2x minus 8, determine x when g of x is 10. So you take 10 and say that's equal to g of x. So 10 is my g of x equals 2x minus 8. This isn't the same as evaluate, like in our last one here, g of 3.1. This is still g of x. We don't know what x is, but we know what the value is once we've evaluated it. It's 10. So that's why the 10 went over here this time, and the 3.1 went in the x spot last time. So for the function g of x equals 2x minus 8, I know that my g of x is 10. So 10 equals 2x minus 8. I'm solving for x. I'll move that 8 over. 10 plus 8 equals 2x. So 18 equals 2x. Solving for x, I'm going to divide both sides by 2. Cancel, cancel. 18 by 2 is 9. And I get 9. And you could check all of these too, right? You could say like 2 times 9 minus 8 equals, so 18 minus 8 equals 10, which is what we were looking for. You can always go back and check. And you probably always should go back and check. Do one more page. Question 10, how many of the following statements are true? We got 1, any set of ordered pairs is a relation. That part's okay, but if they said function, it wouldn't be true. Because we could have a set of ordered pairs that fail the vertical line test that are not a function. But a relation, sure. So this one is true. Maybe I'll do a different color so I can keep track. True. The range of a relation is the set containing the second members of its ordered pairs. So remember, ordered pairs always go x and then y. The second member are the y values. Domain describes x, range describes y. So range is y, range is the second bit. Range should be y, second member is y. Looks good. So the range is everywhere we can expect to find the y values, how far up and how far down, which we usually describe by the highest and the lowest. Next, the dependent variable in a relation is the variable used for the range. So range is y, and the dependent variable is the one that shows up on the x-axis, sorry, the y-axis, and the independent shows up on the x-axis. So the dependent should be on the y-axis, and the range, so that should be y, and the range is definitely describing y. So yeah, this is also good. So far, 3 true statements. Next, a function is a relation. So that part's okay. Functions are relations, yeah. In which each domain value, so the domain values are the x values, or the independent variables, is paired with exactly one range value. Those are the y values, or the dependent variables. What this is saying is that for every spot left or right, if you're looking here, you're going to find only one y value, not 2 or 3 or 4 or 5. If you found more than one y value at the same x spot, so if you looked over here, you're expecting to find just one. But if you find another or another or another, then you are starting to fail that vertical line test of a function. So the sentence is saying a function is a relation where you only find, if you look here, you only find 1. If you look here, you only find 1. If you look there, you only find 1 y value. No matter where you look on the x-axis, you look there, you only find 1 y value down there, or 1 y value down there, or 1 y value up there. Never more than 1. So this is also a true statement. All 4 of these are true statements. Question 11, this is a graph. The function f of x equals 0 when the x has a value of a. So what's a? So f of x equals 0. This is our y value is 0. We're looking for when the y value is 0. That's along the x-axis. We are looking for the x-intercept. The x-intercept is right there, 1 and a bit. So we're looking for an answer that's halfway, or not halfway, but partway between 1 and 2. Looks like a little bit closer to 1. So fx equals 0. F of x is 0 when x is equal to what? That means we want to solve for x. So I'm going to move my x term over because it's negative. I'd like it to be positive. So positive 3x equals 4. X will be equal to 4 over 3. I've divided both sides by 3, right? Cancel, cancel. So x is 4/3. When x is 4/3, which is a little bit over 1, right? That's 1 1/3. A little bit over 1. That looks like we're about right. So a is equal to 4/3. It says also the value of f of negative 1 works out to be b. So f of negative 1 is equal to, so negative 3 times negative 1 plus 4. This means evaluate this expression, this function, at negative 1. So negative 3 times negative 1 is positive 3. And 3 plus 4 is 7. So b is equal to 7. What is the value of a plus b as an improper fraction? Well, 7 plus 4/3, 7 plus 4/3 is the same as 7 plus 1 1/3, which is 8 1/3. And 8 1/3 is one of our options, but it's not the right option because we want an improper fraction. So 8 1/3 as an improper fraction is not like this. That's not improper, although it has the right value. 8.333 repeating also has the right value, but it's written the wrong way. 25/3 is the same as 8 1/3. So 8 1/3, just as a reminder, if we wanted to go from an improper fraction, or from a proper fraction to an improper fraction, 8 1/3, we would take 3 times 8 and then plus 1 as we came around. So 3 times 8 is 24, plus 1 is 25. We would keep the denominator the same. So 25/3. This question here, I just want to point out, you didn't have to do any of this work just because of the way this question was done. This gave you 3 options, so one that said none of these, which I guess maybe could have been the case, but 3 options that all have the same value. 8 1/3, 8.333 repeating, and 25/3 are all the same. And only one of them is an improper fraction. So in the end, this question boiled down to, do you know what an improper fraction is? Which is not really what it was supposed to be testing, but oh well. Okay, I'll stop this video and move on to the next.